Good evening, children.
Good evening.
Good evening. Kindly turn on your videos, children. I've shared my screen. Is it visible, children?
Yes, ma'am.
All right. So from where are we supposed to continue? I think this one. Am I right? Tell me, see the last question in your notebook. Did we finish this one?
No, ma'am.
Okay, then check this. Have we finished this?
Yes, ma'am.
All right, so I think we should continue with the 15th one. All right, so if the zeros of f of x is equal to 2x cubed, the polynomial f of x is 2x cubed minus 15x squared plus 37x minus 30. If the zeros are an AP, find them. So how do you assume the zeros in AP? How do we assume the zeros if they are in AP, children? What are the zeros of a cubic polynomial? Yeah, what are the zeros of a cubic polynomial?
Alpha, beta, and gamma, ma'am.
Alpha, beta, and gamma. Alpha, beta, and gamma. How do we assume alpha, beta, and gamma?
Ma'am, alpha is equal to A minus D.
Alpha is A minus D. What about beta?
A,
Beta is
ma'am.
equal to A.
And gamma?
A
A
plus
plus D.
A plus D. So this is how we assume. This one, the given polynomial is a cubic polynomial. The given polynomial is a cubic polynomial. Alpha, beta, and gamma are the three zeros of a cubic polynomial. And when the zeros are in AP, this is how we assume. Let alpha be A minus D, beta be A, and gamma be A plus D. Okay, so it's given that the zeros are in AP. So don't write, just listen. So let the zeros be alpha, beta, and gamma. Let alpha be A minus D. Do not write now. Beta be A and gamma be A plus D. Now what do we know about the sum of the zeros? Sum of the zeros is equal to minus B by A, right? Sum of the zeros is equal to minus B by A. What is minus B? What's the value of B?
minus 15.
Minus 15. So minus B minus 15 by A 2, which is 15 by 2, which is 15 by 2. So which means A minus D plus A plus D. These are the values of alpha, beta, and gamma. These are the values of alpha, beta, and gamma. The sum is equal to 15 by 2. Minus D plus D gets cancelled. A plus A is 3A. 3A is equal to 15 by 2. So A is equal to 15 by 2 divided by 3. So it will be here 3. 3 ones are 3 fives are. So A is equal to 5 by 2. So we got the value of A. We got the value of A. See, what is the question? We have to find the zeros. We need to find the values of alpha, beta, and gamma. We need to find the zeros. That is, we need to find the values of alpha, beta, and gamma. We found A is 5. Okay, in order to find the values of alpha, beta, and gamma, we need the values of A and D. If you know the value of A, if you know the value of D, you can find alpha, beta, and gamma. Because see here, what is alpha? A minus D. What's beta? A. What's gamma? A plus D. So if you know the values of A and D, if you know the values of A and D, you can find the values of alpha, beta, and gamma. And we already found beta. Beta is A and A is 5 by 2. We already found 1 0 is 5 by 2. We already found 1 0 is 5 by 2. Am I audible and clear, children?
Yes, ma'am.
Yes, ma'am.
Priyanka, am I audible and clear?
Yes, ma'am. Yes, ma'am. Ma'am, I only joined today, so I don't know what has happened in the class before.
Correct. Yeah. So I'll talk to you at the end of the session, Priyanka.
Okay, ma'am.
All right. Yeah. Just try your best to understand. Have you learned polynomials in
Okay,
school?
ma'am. Yes, ma'am.
Okay, you can relate sort of, but this is not from NCRT.
Yeah, ma'am. They said it was omitted. Cubic polynomials.
Yeah, but I don't, meaning the deleted portions, will be useful for higher classes.
Okay,
Yeah,
ma'am.
you might not need it now for 10th standard, but ahead in 11th and 12th. So you will be learning it here. All right, so we got beta is equal to A. Beta is A, meaning A is 5 by 2. So we got the value of beta. We got the value of beta. Now next is to find the values of alpha and gamma. What's the other condition we know, children? What's the other condition we know? We know alpha, beta, gamma is equal to minus D by A, right? We know alpha, beta, gamma is equal to minus D by A. So that means A minus D into A plus D. The product of the zeros is equal to minus D by A. What's the value of D? What's the value of D?
$30.
30 or minus 30? What's the standard form, Ramanathan? Ramanathan, what's the standard form of a cubic polynomial? AX cube.
Yes. Yes, cube.
Class, what's the standard form of a cubic polynomial?
Bx square plus cx plus d.
Bx squared plus cx plus d.
Yes.
Ax cube plus bx squared plus cx plus d. So when you compare, what is d? Minus 30, right?
Yes.
The value of A is 2. The value of B is minus 15. C is 37 and D is minus 30.
Yes.
Yeah, so what is minus D by A? Minus 30 by A. Oh. Yeah, so A minus D into the product of the zeros. The product of the zeros is equal to 15. But you know A is 5 by 2. You know A is 5 by 2. So when you substitute that, you can find the value of D. And as I told you, when you know the values of A and D, you can find the zeros, the 3 zeros. So you can see the answer on the next slide. So see here, children. Again, don't start writing. This class you'll only be taking screenshots and complete it by the weekend. So you can see here, let alpha be a minus d, beta be a, gamma be a plus d. Sum of the zeros minus b by a. I told you why I use capital letters, because we already have a small letter a here. So again, writing minus b by a is confusing. So since we already have small letter a here, I've used a capital letter minus b by a. And as you just understood, sum of the zeros is minus b by a. So the sum of the zeros minus b by a. This is what we just worked. A is equal to 5 by 2. Now the next condition, alpha, beta, gamma is equal to d by a. Alpha, beta, gamma is equal to d by a minus d by a. Sorry, made a mistake while typing. Made a mistake while typing, children. It's minus d by a. Okay, so it's 30 by 2, which is 15, minus d by a. So it'll be minus 30 by 2, which is 15. So that means a minus d into a plus d is equal to 15. And you know, oh God, again, I've made a mistake while typing. A minus d into a plus d. A minus d into a plus d, children. Typing error. Okay, is equal to 15. So you know what is a minus d into a plus d? A minus d into a plus d is, it's like x minus y into x plus y. X square minus y square. Identity. Identity. A minus d into a plus d is a square minus d square. Is a square minus d square. X plus y into x minus y. 8th standard. X plus y into x minus y is equal to x square minus y square. Is equal to x square minus y square. So a minus d into a plus d is a square minus d square, and this into a here. Then I've substituted the value of a. A we got is 5 by 2. A is 5 by 2. So in place of a, 5 by 2. In place of a, 5 by 2. So children, when you solve this, you can find the value of d. When you solve this, you can find the value of d. How do you solve this? This 5 by 2, I've taken it to the other side. 5 by 2, I've transposed. You can see I've transposed 5 by 2. So it becomes 2 by 5. 15 into 2 by 5. 5 by 2, the whole square is 25 by 4 minus d square. 5 by 2, the whole square is 25 by 4 minus d square. 5 by 2 transpose, it becomes 2 by 5. Now when you simplify this, 5 ones are, look at the screen, 5 threes are. So 3 into 2 is 6. That's what you see here. 5 ones are, 5 threes are. 3 twos are 6 is what you see here. And when you transpose this, minus 25 by 4. Minus 25 by 4. So minus d square is equal to 6 minus 25 by 4. You're just solving for d, children. See, this equation has only d. This equation has only d. You're solving this. How will you solve it to find the value of d? This equation has only d. You're solving it to find d. That's all. So you first transpose 5 by 2. It becomes 2 by 5. And this 5 by 2, the whole square is 25 by 4 minus d square. All right. So on simplifying this, you get 6. And this is transposed minus 25 by 4. LCM. LCM 6 minus 25 by 4 LCM. You get minus d square is equal to minus 1 by 4. Minus d square is equal to minus 1 by 4. Minus on either side gets cancelled. So d is equal to plus or minus the square root of 1 by 4. So d is equal to plus or minus 1 by 2. So we found the value of d, or in fact the values of d. We found the values of d. What's the correction here, children? This is d, this is minus. When you take a screenshot. Yeah, so we found the values of d, children. We found the values of d. Now we have a and b. What did we understand when we started? So we need to find the zeros. That is, we need to find alpha, beta, and gamma. To find alpha, beta, and gamma, you need the values of A and D. We already found the value of A, 5 by 2. And now we got D, 1 by 2, plus 1 by 2, minus 1 by 2. So when A is equal to 5 by 2 and D is 1 by 2, let's find alpha, beta, and gamma. Alpha, beta is already known to us. Beta is A is 5 by 2. So alpha, A minus D. So you find the value of alpha, and gamma, A plus D. So this is gamma. Beta, we already know. Beta is A. Beta is A, right? Beta is A. A is 5 by 2. A is 5 by 2. So the zeros are 2, 5 by 2, and 3. The other case is when A is 5 by 2 and D is minus 1 by 2. The other case is when A is 5 by 2 and D is minus 1 by 2. In that case, alpha, beta, and gamma. Beta is 5 by 2, children. Beta is 5 by 2 because beta is A. That's 5 by 2. So I found alpha and gamma. Alpha and gamma. A minus D and A plus D. When A is 5 by 2 and D is minus 1 by 2. So what do we get? 2, 5 by 2, and 3. The zeros are the same. 2, 5 by 2, and 3. Or 3, 5 by 2, and 2. So the zeros are the same. It's just that the order is different. That's all. So the zeros of the given cubic polynomial are 2, 5 by 2, and 3. Or 3, 5 by 2, and 2. The zeros are the same. The values are the same. Please go through the slide. See, it's important to understand how the entire process works. That's all. So what's the first thing, children? When the zeros are in AP, we assume the zero. See, it's a cubic polynomial. We'll start from there. It's a cubic polynomial. So when it's a cubic polynomial, alpha, beta, and gamma are the zeros. Alpha, beta, and gamma are the zeros. And since they are in AP, we assume them to be A minus D, A and A plus D. That's how we begin. And then we use the condition, the relation between the zeros and the coefficients, sum of the zeros minus B by A. Working that, we get the value of alpha, 5 by 2. Then we work the other condition, alpha, beta, gamma is D by A. Working that and using the value of A, 5 by 2, we are able to find D, which is plus or minus 1 by 2. So we got the value of A and D. Now let's find alpha and gamma. When A is 5 by 2 and D is 1 by 2, when A is 5 by 2 and D is minus 1 by 2. Yes, children, please take a screenshot. Please take a picture and complete this. Done? Done, children?
Yes, ma'am.
Yes, ma'am.
Keep your videos turned on, children. All right. Find the condition that the zeros of the polynomial f of x, which is again a cubic polynomial, may be in AP. You need to find the condition. You need to find the condition so that the zeros of the polynomial, it's a cubic polynomial. It's a cubic polynomial. You need to find the condition so that the zeros are in AP. So this we have understood a similar sum earlier. We have understood a similar sum earlier. See here. So this is the given cubic polynomial. This is the given cubic polynomial. And since the zeros should be in AP, we assume we assume alpha, beta, and gamma to be A minus D, A and A plus D. And since we have A here, the small letter A, I'm using capital letters for the coefficients A, B, C, and D. This is AX cube plus BX squared plus CX plus D. AX cube plus BX squared plus CX plus D. So on comparing, you see A is 1. The coefficient of x cubed, A is 1. The coefficient of x squared, 3p. B is 3p. The coefficient of x, C is 3q. And D, the constant is R. The constant D is R. So as usual, we find the sum of the zeros, which is, my God, I've made so many mistakes while typing, sorry. So the sum of the zeros is minus B by A. The sum of the zeros is minus B by A. So you can see minus 3p by 1, which is minus 3p. Correct, children? You need to first compare the given cubic polynomial with the standard form ax cubed plus bx squared plus cx plus d. Get the values of a, b, c, and d. You can see here a is 1. B is, take out the x squared. This is b. Take out x. This is c. And this is d. So write out the values of a, b, c, and d. Then since the zeros must be in AP, alpha, beta, and gamma are A minus D, A and A plus D. Now the sum of the zeros is given by minus B by A. So substitute. So the sum of the zeros is minus 3p. So which means A minus D into A plus D is equal to minus 3p. So minus D and plus D gets cancelled. So 3A is equal to minus 3p, or A is equal to minus p. How A is equal to minus p? Because 3 and 3 gets cancelled, so A is equal to minus p. A is equal to minus p. So as you've understood in the last class, beta is A. Beta is A. And we found A is minus p. A is minus p. That means beta is minus p. One of the zeros is minus p. And I also told you that when the coefficients are not completely numerical, when the coefficients are numerical, you will get numerical values for alpha, beta, and gamma. When the coefficients are not completely numerical, you will not get numerical values for alpha, beta, and gamma. So you see here beta is minus p. Beta is minus p. How? Because beta is A. Beta is A. Beta is A. And what is A? It's minus p. So that means beta is minus p. Beta is minus p. And when we say beta is minus p, we know that. So last class I gave you an example. If beta is minus p, f of beta is always 0. F of beta is always 0. F of alpha is always 0. F of alpha is always 0. F of beta is always 0. F of gamma is always 0. Recall from the last class. So f of beta is 0. This is because beta is a 0 of the cubic polynomial. Now beta is minus p. So f of minus p is 0. Beta is minus p. So f of minus p is 0. Now this is the condition. So we need to work this. How do you work f of minus p? In the polynomial, this is of 9th standard. In the polynomial, wherever there is x, use minus p. In the polynomial, wherever there is x, use minus p. Wherever there is x, use minus p. In the polynomial, wherever there is x, use minus p. So see here, x cubed. X cubed. 1 minute, children. Just a minute. Yeah, I'm back. So I was telling you that since alpha, beta, and gamma are the zeros, f of alpha, f of beta, f of gamma, all will be 0. The value will be 0. So here beta is minus p. We got beta as minus p. So f of beta is equal to 0. That means f of minus p is equal to 0. So how do you work f of minus p? How do we work? In the polynomial, wherever there is x, use minus p. Use minus p. Wherever there is x, use minus p. Do we all understand that? Is equal to 0. Is equal to 0. Let me make it clear in case you don't understand. So see here, this becomes minus p cubed. Minus p cubed. X cubed meaning minus p cubed. Plus 3p into x square. X square meaning minus p the whole square. Plus 3q into x meaning minus p. Plus r. R is r. Only x is replaced with minus p. This is how you express f of minus p. F of minus p is what is this? Is equal to 0. Is equal to 0. This is what you see here. In the polynomial, wherever there is x, we use minus p. So minus p the whole cubed is minus p cubed. And here minus p squared. Minus p into minus p is p. Minus p into minus p is p. 3p into p is 3p into p. Sorry, 3p into p squared is 3p cubed. Minus 3p cube. Minus 3p cube. Minus into plus is minus 3p cube plus r is equal to 0. So minus p cubed. When you multiply this, you get plus 3p cubed minus 3p cube plus r is equal to 0. Like terms, simplify. 3p cubed minus p cubed is 2p cubed. Simplify the like terms. Simplify the like terms. So 2p cubed minus 3p cubed plus r is equal to 0 is the required condition. That is to be satisfied by the coefficients so that the zeros may be in AB. We have done a similar one in the last class, children. Got it, all of you? Any questions related to simplification? No doubt. Okay. Yeah, this is a similar one. You can try this yourself. Instead of asking you to find the condition, the question is just put in a different way. It is exactly like the previous one. It's exactly like this. Here they are asking you to find the condition. Here they have given you the condition. The condition is 2b cubed minus 3abc plus ad square is equal to 0. Instead of asking you to find the condition, they are saying prove that. So like when you work this, you got this condition, right? So when you follow the same procedure, you will get this finally. You will get this condition finally. You will get this condition finally. It's similar to the earlier one. It's very similar to the earlier one. See here, same steps. Given cubic polynomial, values of a, b, c, and d. Now here I've used alpha, beta, and gamma to be p minus q, p, and p plus q. I told you in the last class because we already have a and d in the polynomial f of x. We already have a and d in the polynomial f of x. So again, a plus d, a minus d will be confusing. So I've used different letters. Instead of a minus d, a and a plus d, I've used p minus q, p and p plus q. Instead of a minus d, a and a plus d, I've used p minus q, p and p plus q. So similar working. See here, we find p is same thing. Sum of the zeros is minus b by a. Sum of the zeros is minus b by a. So you work that and find the value of beta. That is, you get p is equal to minus b by a. But p is nothing but beta. P is beta. So beta is minus b by a. And we know f of beta is 0. So that means f of minus b by a is 0. So in the polynomial, sorry, not that. In this polynomial, wherever there is, wherever there is x, use minus b by a. So see here, when you work this, you will get this condition. Then that's what you have to prove. Instead of asking you to find the condition, they have given you the condition and asking you to prove that. Yeah, take a screenshot, children. The simplification I'll just explain. So when it is minus b by a the whole cubed, it means it's minus b by a into minus b by a into minus b by a. Minus b by a the whole cubed. Okay, so minus into minus plus, plus into minus minus. B cube by a cube. That's what you see here. And this one, minus b by a the whole square. Minus b by a into minus b by a. So plus b square by a square. So that's what you see here. And when you multiply this one, minus 3bc by a, minus 3bc by a, plus d is equal to 0. So here, a and a cubed you can cancel. A and a cubed you can cancel. You'll get a square here. So minus b cubed by a square. Minus b cubed by a square. 3b into b square. 3b cubed. 3b into b square is 3b cubed by a square. Minus 3bc by a plus d is equal to 0. Now the common denominator, a square, a. The common denominator is a square. The common denominator is a square. So take the LCM. Take the LCM. The common denominator is a square. So it's exactly like you do work with LCM. So this is already a square, so you will get minus b cubed. This is also a square, so you will get plus 3b cubed. Here there's only a, so you should multiply this one by a, because a square is the common denominator. So multiply by a. So you will get minus 3abc. And here you will have to multiply by a square. A square. LCM, just the way you do the LCM. Then on cross multiplying, a square into a, a square into 0. On cross multiplying, a square into 0 is 0. 3b cubed minus b cubed is 2b cubed. Simplifying the like terms, 3b cubed minus b cubed is 2b cubed. Minus 3abc plus a square d is equal to 0, and that's what we had to prove. I told you the working is very similar to the earlier one. In the earlier question, we had to find the condition. Here you will have to just prove the condition. This is the condition. They've given you the condition. You just have to work and prove the condition. Take a picture, children. Yeah. So how do you assume the zeros when they are in AP? Yes, class. How do we assume the zeros when they are in AP?
Ma'am, alpha is equal to a minus t and beta is equal to a and gamma is equal to a plus t.
What is the sum of the zeros given by?
Minus b by a.
Yeah, what is the value of, so minus, what's the value of B?
Minus 12.
By A, what's the value of A?
1. 1.
So what is alpha? A minus D. What's beta? A. What's gamma? A plus D is equal to 12. Is equal to 12. So minus D and plus D cancel. So you get 3A is equal to 12. A is equal to 4. And who's A? Beta. Beta is equal to 4. Beta is equal to 4. Beta is equal to 4. What is f of beta? What is f of beta? What is f of alpha? What is f of beta? What is f of gamma?
0.
All-
ma'am.
0.
0.
0.
0. F of alpha, f of beta, f of gamma is always 0. So that means beta is 4. So f of 4 is equal to 0, correct? F of 4 is equal to 0. How do you work f of 4? How do you work f of 4?
4 cube
4 cube minus 12 into 4 square plus 39 into 4 plus k.
Plus k is equal to 0. So don't you think when you work this, you can find the value of k?
Yes, ma'am.
Yeah, so simply work that and find the value of k. So see here. So once you work with that condition, sum of the zeros is equal to minus b by a. When you work with that condition, you're able to find the value of a. But a is beta. Beta is a. Beta is a. So that means beta is 4. But we know f of beta is 0. So that means f of 4 is 0. So now what is f of 4? This is f of 4. Wherever there is x, you should use 4. Is equal to 0. So solve this and find the value of k. That's a question. Find k is a question. Find k is a question. Take a picture, children. Done?
Yes, ma'am.
All right. So f of x here given is in the standard form. Class, use the digital hand. Raise hand. Hitesh, Priyanka, and Sashmin, are you all there?
Yes, ma'am.
Yes, ma'am. The hand raise option is not working for me, ma'am.
Ma'am, can I leave and join?
Come again, Sashmin. I didn't get you.
Can I leave and join?
Yeah, sure.
Because
Yes, children. So what is f of x given? Ax cubed plus bx squared plus cx plus d. And what do you think about this? This is the standard form of a cubic polynomial, right? This is the standard form of a cubic polynomial. Ax cubed plus bx squared plus cx plus d is a standard form of a cubic polynomial. What is alpha plus beta plus gamma?
minus b by a.
What is alpha? What is alpha beta plus beta gamma plus alpha gamma?
C by a.
And Harini, what is alpha beta gamma? Harini, what is alpha beta gamma? I can't hear you.
Minus D by A, ma'am.
Okay, minus D by A. Minus D by A. All right. Now we need to find the value of 1 by alpha plus 1 by beta plus 1 by gamma. What's the LCM of alpha, beta, and gamma? What will be the common denominator for alpha, beta, and gamma? Class, what's the common denominator? Yeah?
Alpha, beta, gamma.
Oh, the answer is from Sneha, Arani and Sneha, is it? Who said alpha, beta, gamma?
Ma'am?
Yeah. Arani or Sneha?
Ma'am, both of them, ma'am.
Both of you. Okay. All right, very good. Alpha, beta, gamma. So what in the numerator here? 1 minute. Priyanka?
Ma'am,
Yeah.
one alpha, beta, gamma.
No, alpha, beta, gamma is the common denominator. So what will happen in the numerator?
Ma'am, one
Alpha, beta, gamma plus
No, I'm not asking
alpha,
you.
gamma.
I'm not asking you. I'm not asking you. The question is to Priyanka.
1 beta gamma plus 1 alpha gamma plus 1 alpha beta.
Very good. But we can ignore that one, no? Because anyways,
Yes.
yeah, very good. Tell me the answer without one.
Beta gamma plus alpha gamma
Very
plus alpha beta.
Very good, very good. And Priyanka, what is the value of, so see, what is this? What is the numerator? Alpha beta plus beta gamma plus alpha gamma, right? In a different order. The numerator is alpha beta plus beta gamma plus alpha gamma in a different order. And what do you see? What's the value of, what is the value of alpha beta plus beta gamma plus alpha gamma?
C by A, ma'am.
Come again?
C by A, ma'am.
C by A divided by, what's the value of alpha beta gamma?
Minus D by A.
Minus D by A. So what will happen in the next step? C by A into,
A by minus D.
okay, or minus A by D. Very good. So A and A will get cancelled. So the value is minus C by D. So the value of 1 by alpha plus 1 by beta plus 1 by gamma is equal to minus C by D. Don't write down, children. I'll show you the answer slide. Don't write down. This is very important. So the LCM is alpha, beta, gamma. On taking the LCM, the numerator, you should understand the numerator because the common denominator is alpha, beta, gamma. There is alpha here. So you should multiply this with beta, gamma. There is beta here. So you should multiply this with alpha, gamma. There's gamma here. So multiply this with alpha, beta. LCM, the usual thing, nothing different. Whatever you do with numbers, same thing here. Then this is the value of the numerator divided by, this is the value of the denominator. And when we simplify, we get minus C by D. Next. Now I want you all to complete this identity which we learned last year. What is x plus y plus z the whole square? We have seen this last year. What is x plus y plus z the whole square?
X square plus y square plus z square plus 2xy plus 2yz plus 2zx.
Very good. Very good, Ramanathan. Very good. So x plus y plus z the whole square is x square plus y square plus z square plus 2xy plus 2yz plus 2xz. So this is what 9th standard has taught us. And this identity is going to be useful in finding the value of alpha square plus beta square plus gamma square. So I'm going to write the same identity using alpha beta gamma. I'm going to write the same identity using alpha beta gamma. Alpha square plus beta square plus gamma square plus 2 alpha beta plus 2 beta gamma plus 2 alpha gamma is equal to alpha plus beta plus gamma the whole square. The identity you've seen last year is, I'll write it here, x square plus y square plus z square plus 2xy plus 2yz plus 2xz is equal to x plus y plus z the whole square. This is what we have seen last year. We are using the same identity, but in place of x, y, z, we use alpha, beta, and gamma. We reconstruct the identity using alpha, beta, and gamma. I'm waiting for you to understand, that's all. Got it, children? Can I continue?
Yes, ma'am.
Yeah. So now alpha square plus beta square plus gamma square plus we'll take out 2 common. Alpha beta plus beta gamma plus alpha gamma is equal to alpha plus beta plus gamma the whole square. We just taken out 2 common. Now we have to find this one. So let this remain. We have to find alpha square plus beta square plus gamma square. So let this be there. Plus 2 into, what is alpha beta plus beta gamma plus alpha gamma, children?
C by A, ma'am.
C by A. So substitute C by A is equal to, what is this? Alpha plus beta plus gamma
Minus B by A.
minus D by A. That's all. Work this and find the value of alpha square plus beta square plus gamma square. Take a picture. This is for the first part. Take a picture. This is the answer for the first part. Please take a picture. And this is for the second part. So here I've just written it straight away by taking 2 common children. So don't get confused. I've not alpha square plus beta square plus gamma square plus 2 alpha beta plus 2 beta gamma plus 2 alpha gamma is equal to alpha plus beta plus gamma the whole square. And then we take out 2 common. Then we take out 2 common. Then you just transpose, take the LCM and get the value. Yeah. Tarun Ishwaran, you're, yeah. So minus B by A the whole square. is b square by a square. And on transposing this, minus 2c by a. 2c by a minus 2c by a. LCM a square got it, children?
Yes, ma'am.
Yes, ma'am.
Yeah, this again is important. Who can tell me the LCM? Okay, before that, f of x is equal to x cubed minus px squared plus qx minus r. So we'll have to compare this with ax cubed. We'll have to compare this with ax cubed plus bx squared plus cx plus d. So what is the value of a? What's the value of A?
1, ma'am.
1. What's the value of b?
Minus B.
What's the value of c?
Q.
Q, ma'am.
What's the value of d?
Minus R.
Minus
Minus R.
Minus r. What will be alpha plus beta plus gamma?
Minus B by A.
Minus b by a. So it will be minus b. This is b by a. So it is p. Correct?
P. Yes, ma'am.
Okay. So what is alpha beta plus beta gamma plus alpha gamma?
C by A.
C by
C
a.
by A.
By 1, which is q. And what is alpha beta gamma?
Minus D
Minus
by
B
A.
by A.
Minus d by a. So minus r by 1. So r by 1 or r. Don't write anything. What's the LCM of alpha beta, beta gamma, and alpha gamma?
Gamma plus alpha plus beta by alpha beta gamma.
No, I asked you what's the LCM of the denominators.
Alpha beta gamma.
Alpha beta gamma is the LCM. Alpha beta gamma is the LCM. The LCM of alpha beta plus beta gamma plus alpha gamma is alpha beta gamma. So here we have alpha beta. So you need to multiply the numerator with gamma. Here you have beta gamma. You have beta gamma. So you need to multiply the numerator with alpha. And here you have alpha gamma. So you need to multiply the numerator with beta. So that way you get 1 into gamma, gamma plus 1 into alpha, alpha plus beta. So what is the numerator? What's the numerator?
P, ma'am.
Alpha plus beta plus gamma. So it's P by, what is alpha, beta, gamma?
R.
R. So the value is P by R. The value is P by R. So what's important is the LCM of alpha, beta, beta, gamma, and alpha, gamma is alpha, beta, gamma. Alpha, beta, gamma. Take a picture, children. Okay, I've just worked it in a different way here. So after taking the LCM, so nothing to get confused. After taking the LCM, so this is alpha plus beta plus gamma. So which is minus b by a. You can also do it like this. divided by alpha beta gamma, which is minus d by a. So it's minus b by a into a by minus d. A and a will get cancelled. Minus and minus cancels. So b by d. You can also work it like this, b by d. What's the value of b? Minus p. What's the value of d? Minus r. So minus p by minus r, which is p by r. We'll do one thing. You can take a picture of, I cleared the slide, is it? Okay. Is it confusing, children? Anyways, it's fine. So, okay, let me do it here itself. So you can work it like this, or here what I've done is alpha plus beta plus gamma is minus b by a divided by alpha beta gamma is minus d by a. Then reciprocal, a and a cancels, minus and minus cancel. So b by d we get, and the value of b is minus p. The value of d is minus r. So minus p by minus r, minus cancels p by r. You can also do it like the way I explained. Alpha plus beta plus gamma is equal to minus b by a, which is minus p by 1, which is p. And alpha beta gamma is equal to r. We just understood earlier as r. So at this point you can substitute. The numerator. The numerator is p. The denominator is r, p by r. Take a picture, children. So again, this goes down to 9th standard. There is one condition given to us. A plus b is equal to 4. The other condition you can get from this one. X plus 2 is a factor of f of x. So in the chapter polynomials, factor theorem and remainder theorem last year, x plus 2 is a factor of f of x. So if x plus 2 is a factor of f of x, equate x plus 2 to 0. So we get x is equal to minus 2. Since it's a factor, f of minus 2 is equal to 0. 9th standard. Since it's a factor, f of minus 2 is 0. The remainder will be 0. This is the remainder. When you divide f of x by its factor, the remainder will be 0. When you divide f of x by its factor, the remainder will be 0. So remainder is 0. F of minus 2 is equal to 0. I'm not actually explaining this because this of 9th standard. So if you don't understand, we have to go to the details of 9th. X plus 2 equated to 0. So you get x is equal to minus 2. So f of x, that means f of minus 2 now because x is minus 2. F of x is minus 2. So f of minus 2 is equal to what you should write here is you should write the remainder. What is the remainder? When you divide f of x by its factor, the remainder will be 0. So the condition is f of minus 2 is equal to 0. F of minus 2 is equal to 0 is the condition. So now how do you continue? F of minus 2 means In the polynomial, in place of x, we'll have to use -2. F of -2 means in the polynomial, in place of x, we'll have to use -2. So it will be -2 the whole square plus a into -2 plus 2b plus 2b. -2 square plus a into -2 plus 2b is equal to 0. This is equal to 0. Is equal to 0. So simplify that and you get an equation in a and b. When you divide this one by, see this is what you get. When you divide -2a plus 2b is equal to -4. When you divide this by 2 throughout, you get -a plus b is equal to -2. That's the first equation. And the second one is given to you. A plus b is equal to 4 is given to you. -2a plus 2b is equal to -4. When you divide the equation throughout, just a second, children. Thank you, children. Yeah, I was telling you. When you work with the condition f of -2 is equal to 0, we land with something like this: -2a plus 2b is equal to -4. Divide this by 2 throughout. So you will get a -a plus b is equal to -2. So that is one equation. The other equation is given to us in the question. So you know how to solve linear equations. We have learned how to solve two equations. So I have not shown that solving part here. So when you solve the two equations, you will get the values of a and b. The value of a is 3 and the value of b is 1. Take a picture, children. Done? Almost coming to the end of it. So here, if one root of the polynomial, it's a quadratic polynomial, you can see there. It's a quadratic polynomial. F of x is equal to 5x squared plus 13x plus k. So if one root of the polynomial, meaning 1, 0, if 1, 0 or one root of the polynomial is the reciprocal of the other, find k. How many zeros does a quadratic polynomial have? How many zeros
2, ma'am.
does a quadratic polynomial have? No, sorry, I didn't hear.
2,
2,
ma'am.
ma'am.
2 zeros. And what are the zeros?
Alpha and beta, ma'am.
Alpha and beta. Alpha and beta. It's a quadratic polynomial. It's a quadratic polynomial. It has a maximum of 2 zeros, and the 2 zeros are alpha and beta. Yes or no, Harini?
Yes, ma'am. Yes, ma'am.
Okay. So if one, so here we are, so we've been seeing cubic polynomials all the while. This is a quadratic polynomial. You can see here 5x squared. It's a quadratic polynomial. It's a quadratic polynomial. Its zeros are alpha and beta. Its zeros are alpha and beta. And it's given that 1, 0 is the reciprocal of the other. So if 1, 0 is alpha, the other 0 is 1 by alpha. Okay, see, alpha and beta are the zeros. If you take alpha as alpha, beta is the reciprocal of alpha, 1 by alpha. Or you can say let the zeros be beta and 1 by beta also. There's nothing that you should take alpha and 1 by alpha. The meaning should be used correctly. 1 0 is the reciprocal of the other. 1 0 is the reciprocal of the other. So if you call 1 0 as alpha, the other zero is 1 by alpha. So whenever you have the reciprocal, now when it is a quadratic polynomial, what are the two conditions? You know, the sum of the zeros is equal to minus b by a, and the product of the zeros is equal to c by a. This is about a quadratic polynomial. This is about a quadratic polynomial. The sum of the zeros is equal to minus b by a. The product of the zeros is equal to c by a. Now we are going to use this condition. Product of the zeros is equal to c by a. We are going to use this. We are going to use this. Product of the zeros is equal to c by a. Because when the zeros are alpha and 1 by alpha, you know, and when you take their product, they'll get cancelled and you'll get 1. So it's easy to find the value of k. So let me work it for you. See here. Let the zeros be alpha and 1 by alpha. That's the first step. Let the two zeros be alpha and 1 by alpha. That's the first step. We know that the product of the zeros, in the case of a quadratic polynomial, the product of the zeros is equal to c by a. Product of the zeros means alpha into 1 by alpha is equal to c by a. That is k by 5. Alpha and alpha cancels. On cross multiplying, k is equal to 5. And we found the value of k. Got it, children? Go through. One root is the reciprocal of the other. So let the roots or let the zeros be alpha and 1 by alpha. Product is c by a. Go through the slide. Fine, children?
Yes, ma'am.
Okay. And with this, we come to the end of this material, this presentation. All right. So here, if 1 0, this again is a quadratic polynomial. This again is a quadratic polynomial, 4x squared minus 8, 4x squared minus 8kx plus 9. What is given here? 1 0 is the negative of the other. In the earlier one, what was given? 1 0 is the reciprocal of the other. Go back to the earlier one. 0 root. I've explained this to you. 0 root. So here, one root is a reciprocal of the other. One root is a reciprocal of the other. So if one is alpha, the other is 1 by alpha. And here we use the condition product of the zeros is c by a to find the value of k. Here, 1 0 is the negative of the other. So that means if 1 0 is alpha, the other 0 is minus alpha. One is the negative of the other. One is the negative of the other. So like if one 0 is 5, the other 0 is minus 5. If one 0 is minus 3, the other 0 is 3. One 0 is the negative of the other. So if you take one as alpha, the other is minus alpha. So let the zeros be alpha and minus alpha. We know that the sum of the zeros. So here you'll have to use the condition sum of the zeros. No talking, Sneha and Harini. Okay. So sum of the zeros. So here we'll have to use sum of the zeros is equal to minus b by a. Sum of the zeros is equal to minus b by a. There we use product. Because when you multiply alpha and minus 1 by alpha, you will get alpha and alpha will get cancelled and you will get 1. For reciprocal, use product of the zeros. Here we use sum of the zeros. One 0 is the negative of the other. If one is alpha, the other is minus alpha. It's a quadratic polynomial. Only two zeros. Only two zeros. Sum of the zeros is minus b by a. So sum of the zeros is alpha plus minus alpha. The sum of the zeros is equal to minus b minus 8k by a 4 minus b by a minus b is minus 8k. The coefficient of x is minus 8k. That is b by a. So what is alpha minus alpha? 0. This is 0. 0 is equal to 8k by 4. Cross multiply. 8k is equal to 0. Cross multiply. 8k is equal to 0. K is equal to 0 by 8. K is equal to 0. So the value of k is 0. The value of k is 0. So here I've simplified here itself. 4 ones are, 4 twos are like this. And I got 2k. Minus into minus plus. 4 ones are, 4 twos are. So I get 2k is equal to 0. 2k is equal to 0. K is equal to 0 by 2, which is 0. Is it understood, children?
Yes, ma'am.
So remember, when it is when one 0 is a negative of the other, then we say let the zeros be alpha and minus alpha, and we use the condition sum of the zeros is equal to minus b by a, because only when you add these two you will get 0. When one 0 is a negative of, when one 0 is a reciprocal of the other, when one 0 is a reciprocal of the other, alpha and 1 by alpha, we use the condition product of the zeros is c by a. Alpha into 1 by alpha is c by a. So next class, I'll be continuing with, I'll be sharing some videos on polynomials for this weekend. This weekend, I'll be sharing some videos on polynomials. Have I shared anything on polynomials so far? No, right? No, I haven't. Yeah, I know that. I haven't shared any videos on polynomials. So this weekend, I'll be sharing some videos on polynomials.
Ma'am?
Yes?
Ma'am, you saying that identities videos, ma'am.
Correct. Correct. Only that I had sent. Correct. Yes.
Yes, ma'am.
Yeah, there are a few more. Correct. There are a few more. So I'll just share the videos with you. Watch them and we'll continue with them on Tuesday. For Saturday, we'll go back to linear equations. We have more word problems to understand on linear equations. So Saturday's class, we'll go back to linear equations. We'll be understanding how to construct equations for word problems. I'll only teach you how to construct the equations because the solving part, you know, we have seen all the 4 methods, how to solve 2 linear equations in X and Y or A and B. We know how to solve 2 equations, 2 linear equations. Cross multiplication method, substitution, elimination method. So we'll only understand different word problems and we'll learn how to construct the equations. How solving part you will take care. I'll just show you how the presentation will look like. Example. Okay. Let's just understand this one and wind up the session for today. We'll just see this question. In a competitive, so we have switched to linear equations. It's a word problem. So in a competitive examination, 1 mark is awarded for each correct answer, while half a mark is deducted for every wrong answer. Okay, 1 mark. So if you answer correctly, you will get 1 mark. If you answer correctly, you will get 1 mark. If you answer incorrectly, you will lose half mark. Negative marking. Your answer is correct, 1 mark. Your answer is wrong, minus half. You lose half a mark. Jayanti answered 120 questions. So this student Jayanti, she answered 120 questions and she got 90 marks. And she got 90 marks. What is the maximum marks, children, for this paper? 1 question, 1 mark. So 120 questions, 120 marks. Jayanti answered 120 questions and she got 90 marks. How many questions did she answer correctly? So let us say that Jayanti answered. Let us say that Jayanti, she answers X questions correctly. Okay, correct answers. Correct answers, we'll say X. Number of questions answered correctly be X. And number of questions answered incorrectly. Number of questions answered don't write anything incorrectly, be Y. Okay, so she answers X questions correctly and Y questions incorrectly. So total number of questions. Total, see, nothing is given that she omitted some questions. Is there any information about Jayanti did not answer so many questions? No. So we assume that she's attempted everything because there is no information about Jayanti not attempting any question. There is no information. So you cannot assume that she's omitted 10 questions or 20 questions. You cannot assume that. There is no mention about Jayanti omitting any questions. So the assumption is she's attempted all the questions. That's the assumption you can make. She's attempted all the questions. Some are correct, some are incorrect. Jayanti has attempted all the questions. Some questions she attempted were correct, some were incorrect. So the total number of questions is equal to x plus y, because she's answered x correctly, y incorrectly. So total number of questions is x plus y. See, I'm telling you again, there is no mention that Jayanti has omitted or not answered at all any question. There is no information regarding that. So what we can assume is Jayanti has answered all the questions. Some are correct, some are incorrect. Correct question, correct x, incorrect y. So answered correctly plus answered incorrectly will be the total number of questions x plus y, and x plus y is equal to 120. That is the first equation. X plus y is equal to 120 because Jayanti answered 120 questions. It's not given Jayanti answered 120 questions correctly. No, it's not given Jayanti answered 120 questions correctly. Jayanti answered 120 questions. She's answered 120 questions. The total number of questions 120. So x plus y is equal to 120. Now how much she got? 90 marks. So she answers x questions correctly and she gets 1 mark each. So 1 into x minus she loses half a mark. That's why minus half a mark she loses for every incorrect answer. So half into y is equal to 90 marks. This is the second equation. She gets 1 mark for every correct answer. She's answered x questions correctly. If each of them carry 2 marks, 2 into x she'll get. Each of them carry only 1 mark. So 1 into x. 1 into x. X questions correct. 1 mark each. 1 into x she'll get. And y minus because she's losing now. She's losing for every incorrect answer. How much is she losing? She's answered y questions incorrectly and she's losing half a mark for every incorrect question or incorrect answer. So she's losing, no, so minus half y. Like this, the total score is 90. This is the second equation. You need to solve these two equations and find the values of x and y. And once you find x and y, x plus y, supposing you get x is, I'm just saying like 30 and y is 5. So the total number of questions is 35. I'm just telling you, for example, this cannot be the answer for the question. So maybe you'll get x is equal to 100 and y is equal to 20. Whatever. Okay, I'm sorry. You should answer how many questions she answered correctly. Okay, answered correctly. Answered correctly is x. So you should find the value of x. You don't even have to find y. Sorry. You don't even have to find y. You don't even have to find y. How many questions she answered correctly? Correctly is x. So find the value of x and leave it. So you'll have to solve the two equations and find the value of x. So see here, I've solved the two equations and I found the value of x. X is 100. X is 100. How many questions did she answer correctly? Correctly, x. So x is 100. So like this, we'll visit many word problems. In the next class, we'll visit many word problems and we'll understand how to construct the equations. I have all the answers worked, so you will get to take the screenshots to see how the equations are worked. But we'll understand only constructing equations in the classroom. You will have to solve them and find the values of x and y over. All right. So that will be Saturday's session on linear equations. All right, children. So that was it for today's class. All of you, those of raise your hand, lower your hands. Lower your hands, children. Murali Krishna, lower your hand. Yes. Now, class, use the raise hand option. Raise your hand. Tarun E, are you there?
Yes, ma'am.
Okay. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Priyanka, no,
Thank
can
you, ma'am.
stay back. Priyanka, please stay
Yes,
back.
ma'am.